when you're looking at this right now, I want you to tell me which is the upstream side and which is the downstream side. Just by looking at it, how do you know?
It goes up and around.
Okay, now if you couldn't see, if that wasn't open, how would you figure
From
that
the
out?
back side, from high pressure to low pressure.
And also you can tell by the piping. Okay? Your CRD in this application is always going to have a larger pipe leading to the downstream side, so the lower pressure side,
Okay.
because it needs to be able to take off more water than this can put on. Okay?
Okay.
So that's another indicator of which is up and which is downstream, okay? So here's the idea. Here's your upstream side. And water's coming in. It's going through the dole valve. The dole valve is basically allowing the same amount of water through all the time. So if you can imagine, and depending on whether this valve is open or closed, that water is either going to be forced onto the top of the valve or it's going to be allowed to run through.
Now, is this a needle?
That's a needle valve.
Okay.
This is a needle valve.
Yeah.
All of those do is control how quickly this valve opens and how quickly it closes.
So is it restricted this way or restricted this way?
Now, if you're looking at this, the needle's going down like this.
Okay.
Okay, so that means since the needle's pointing down, the water can slide quite nicely past the needle.
Exactly.
Okay, so this one is actually not controlling anything in this direction.
Right.
It isn't until here where the water has to pass through the constriction here and then go down here. So this one actually controls how fast this water comes onto the top of this valve.
So it's restricted this way?
Yeah.
And
Exactly.
not restricted this way.
Right.
Okay.
So this one will control how quickly water goes on top of the valve, but this one controls how quickly water comes off the valve.
Yeah. Okay.
Okay. So, and there's your dole valve, which just controls how much water gets into the system to start with.
You need that.
And it's always a constant amount coming through here.
Okay.
So whatever it happens to be, 0.1 liters per minute or whatever it happens to be, that's what you get coming in here. This one opens and closes based on what's happening on our downstream pressure side. Okay? So if this is closed, all of the 0.1 liter per minute, which this is letting in, is going to get forced onto the top of the valve.
Right.
If this is open all the way, then this one is going to allow that 0.1 liters per second come off here. But if it's really open, like full open, it's going to be looking for more water, so it's going to start pulling water from here.
And opening the valve.
Right.
Right.
Make sense?
Yeah.
Okay. So the next step of this whole process is if we look here, okay, this valve, it controls, is controlled by the downstream pressure. So you can see the pressure inside this sort of main pipe connection here is going to be the same pressure that's in here, that's in the same pressure here, that's in the same pressure that's inside the body here.
Okay.
Okay? So that pressure that's in the downstream side of this valve is transmitted through this line into the interior. Okay? And it doesn't matter which way the water is going. The pressure is still going to be the same.
Okay.
Does that make sense?
Yep.
Okay.
It does.
So when we have a high pressure situation in here, because this is a reverse seated valve, it forces the stem to travel up, which lifts the saddle assembly up, which brings the disc closer to the seat, which closes the valve.
Right.
Okay. So if this is high pressure, so if what happened here is the water passing through the valve here, if this pressure rises too high, and that will happen when your downstream users stop using water, and
That
so
closes.
this pressure will build in here. That high pressure will be transmitted in here, and then this valve will start to close.
Right.
When it closes, that 0.1 liters per minute is then forced, or a fraction of it. It generally don't close all the way. More of it will be forced onto the top of the valve, which pushes the water in here, which forces this stem to travel down,
And close.
which will start to close the valve. Now, this process is very minute, right? We're not talking like open, close, right? So this valve is going to be partially open almost all the time.
So which one is set at a higher?
Okay. This one, let's say we wanted this to maintain a downstream pressure of, say, 70 psi.
Yeah.
Okay, so you'd set this one at 70. And so this valve will modulate itself so that it maintains 70 psi. Now, if this fails, what happens? What's
Closes.
the most common failure?
What is the common failure of this? plugged up? I don't know.
No, the diaphragm fails.
Oh, okay.
Okay?
Yeah.
When the diaphragm fails, what that means is the pressure equalizes inside the main body chamber and on top of the bonnet, in
Okay.
the valve chamber on the top. So when that happens, the only force that's acting on this is the stem, the spring force, which is going to force the stem sort of this direction, which will then move the saddle assembly away from the seat, opening this valve.
Oh, yeah.
So this valve is going to fail open.
Yeah.
So when we talk about
Reverse.
a pressure reducing valve like this, this is a reverse seated, normally open valve.
Right.
Okay, because it fails open. All right. So if this one fails open, what happens in this assembly here? What happens to the water? This is still letting in 0.1 liter per minute. What happens when this fails open?
It starts pulling water.
Yeah, all of that 0.1 liters per second is going to come off, go through the valve and go out. In addition, because it's wide open, because we've got this great big pipe here,
Right.
it's going to start pulling water off the top of
And
here.
opening
and
that
into here.
valve.
So we'll have water coming in from two locations into here and going out, right?
Right.
The big valve will open wide.
Right.
If this fails wide open, this will fail wide open. Okay? We don't want that.
No.
So what we're going to do is we're going to set our CRL, or our pressure relief pilot, such that it's set at 5 or 10 pounds heavier. So
Heavier than this
so
one.
if this one's set at 70, we'll set this at 80.
Right.
Okay? So what's going to happen is, because this one fails wide open, the big valve starts to fail open also, or open, it hasn't failed, but it will start to open wide up, and the pressure in the downstream side will start to rise.
Mhm.
When it hits the 80 psi, some
That starts
interesting
to
things
close.
happen. Well, that one's always closed. So let's go take a look at this guy here. Okay? So what we've got happening here is this guy is a normally closed front-seated valve. Okay? And it's got two completely separate chambers. It's got the valve body chamber, which is here, which allows water to pass through onto the top of the bonnet. Okay? And the other thing that it's got going on here is a sensing chamber. Okay?
That senses pressure off that.
Mm-hmm.
Okay.
Okay? And that's sensing the downstream pressure.
Right. And if
Okay.
it goes above 80,
If it goes above 80, what's going to happen here
it starts to close.
is,
That's this valve.
well, it starts to close it, but how does it start to close it?
Because this starts putting water onto that
Like,
diaphragm.
like right now, when the pressure is below 80 psi, the spring force is winning on this.
Right.
Okay? So it's forcing the stem to be down, which brings the seat in the disc in contact with the seat.
Right.
So this one, unless there's enough pressure in the sensing chamber, the spring will also always be forcing this valve closed.
Right.
Okay, because it's a normally seated valve. If the pressure rises in this little chamber here, this one is going to start to fill up with pressure in here. That it overcomes the spring force, will force the stem to travel in this direction, lifting the seat, or lifting the disc off the seat in the main ball.
And putting water
Yeah.
onto this diaphragm.
And then that will allow this to open, and it puts water on top. Okay? Now here's the ticket. You're still getting water all the time leaving through this valve.
Yeah.
Okay? This is failed open, right?
Right.
Plus you've still got water coming through here.
Right.
Okay? So right now, we need to have this, see how big this pipe is here?
Yeah.
It's got no flow restrictor on it, because it needs to be able to put on more water than we can take off with this big pipe here. Okay? Because right now we've got water that's coming off the top,
Okay. Yeah.
and we've got water coming through here. That
Yeah.
hasn't changed. That's still happening. Okay? And so this has to be able to put on more water than this valve can take off.
Which, that's why the big pipe.
Not a big pipe. Okay? And no flow control. You notice this hasn't got a dole valve.
Mm-hmm.
Right?
Yeah.
Okay.
That's,